All right, so let's have a look at our final question from this series. We've got here the graph of a function, e to the power of x over 2 plus 1. The normal of the graph, where it crosses the y-axis. So here we've got 90 degrees to the curve. And we want the area shown in that graph. Now we're going to, for area, we have to use the integral. And we've got to know this value for x here so that we could go between 0 and that value for x. First of all, let's get the equation of the normal so that we can find out where it crosses the x-axis. At x equals 0. So we want the equation of the normal at x equals 0. So where does it cross? Where does y equals e to the power of x over 2 cross the y-axis? And that is when 0 equals e to the power of x over 2, not y is 0, x is 0. Is equal to 2. So it crosses at 2 at the y value of 0. What is the gradient? Well, the gradient of y equals e to the power of x over 2 plus 1 is the derivative dy dx. And here's an application. The derivative of e to the power of x over 2 is e to the power of x over 2 times by the derivative of that bracket, a half. And when x is 0, at x equals 0, the gradient will be e to the power of 0 times a half equals a half. So if the gradient is 1 over 2 there, therefore the gradient is negative 2 over 1. So you have to reciprocate it and change it to negative. Okay, now we know this has a gradient of negative 2 over 1. The gradient is negative 2. So y equals mx plus c for this normal. So y equals negative 2x plus 2. Where does it cross the x-axis when y equals 0? Negative 2x plus 2. Therefore, negative 2 over negative 2 equals x equals 1. It'll cross at x equals 1. So now we've discovered that it crosses at x equals 1. We can now get the area from 0 to 1. First of all, underneath our function, which is e to the power of x over 2 plus 1. And then we have to subtract the area underneath that line, which is negative 2x plus 2. And we'll go to dx. Okay, so the integral of x over 2 is e to the x over 2. Divide by a half, right? Because we're doing integrals, we divide by the derivative, plus 1x, because the derivative of 1 is x, minus, and let's get the derivative here. That will become plus and that will become minus. So plus 2x is 2x squared over 2. We raise the index by 1 and divide by the new power. And the integral of minus 2 is minus 2x. And we go all the way between 0 and 1. So let's substitute a 1 in here. And we've got, we're running out of space, but let's substitute 1 and then substitute 0. So 1 is 2 e to the power of a half plus 1 plus 2 over 2 plus another 1 minus 2 times 1 minus 2. Okay. And then substitute 0 in there and subtract. When you substitute 0, you get a 0 there, you get a 0 there, you get a 0 there, but you don't get a 0 here. You get a a 2e to the power of 0. And we're going to end up with 2e to the power of a half minus 2. And that is the area. 2e to the power of a half minus 2. Lovely question.